Today, we are going to talk about the methods of purification of water for both domestic and laboratory use. All of us use water in our homes and make it dirty. Dirty? Are you surprised? Rich in Latin, mixed with oil, black-brown water that goes down the drains from sinks, showers, toilets, laundries is dirty, and it is called wastewater. This used water should not be wasted. We must clean it up by removing pollutants. Water purification is the process of removing undesirable chemicals such as motor oil and paint, and also removing biological contaminants, suspended solids and gases from contaminated water. These biological contaminants may include microbes, while the suspended solids may include mold suspended in water. The goal is to produce water fit for a specific purpose. Most water is purified for human consumption, that is, drinking water. But water purification may also be designed for a variety of other purposes, including meeting the requirements of medicine, such as the use of a pure water distiller for dental medicine. It is also applied in pharmacology, where it can be used to determine the concentration of arsenic present in water. Arsenic is a metal. With regards to chemical and industrial application, it can be used for the cleaning of shipyards. In general, the methods used include physical processes such as filtration, where we make use of a filter funnel, sedimentation, where the suspended particles found in the water are allowed to settle, and distillation, where the contaminated water is heated and the vapor evaporates and cools, with the distillate being collected in another container. We also have biological processes such as slow sand filter, where we make use of sand to filter the contaminated water. We can also have biological active carbon, where the activated carbon is a material prepared in such a way that it can remove a certain number of organic materials from the wastewater. We can also have chemical processes, and these processes include flocculation. Flocculation involves the use of a coagulant. Coagulants, for example, we can have aluminum sulfate. It is being used as a coagulant in order to purify the water. Another chemical process is chlorination, and in chlorination we make use of a bleach containing chlorine, and we can also have ultraviolet light. Here we make use of the sun to heat the contaminated water. So the use of electromagnetic radiation such as ultraviolet light from the sun can be used to purify water. The purification process of water may reduce the concentration of particulate matter, including suspended particles such as sticks, parasites such as that which causes dysentery, bacteria such as that which causes cholera and typhoid, algae, viruses, fungi, and a range of dissolved and particulate material derived from the surface that water may have made contact with after falling as rain. It is not possible to tell whether water is of an appropriate quality by visual examination, that is, looking with your eyes. Simple procedures such as boiling, which makes use of the following equipment. We have the water container, intense heat, preferably a fuel-effective stove. The process involves placing the water in a container such as a pot and heating until it boils. The water should be allowed to boil for at least 10 minutes. Once cooled, the water will be ready to use. It is important to note that this technique is not sufficient for treating all the possible contaminants that may be present in water from an unknown source. Although it is a simple and effective method of purification that will kill many bacteria through the intense heat, it can sometimes be difficult, time-consuming, and cause inefficient because of the high volume of fuel used. It will not also remove mud and suspended or dissolved compounds such as oil in water. Now, let's look at the processes which are commonly used in water purification for domestic use. Some or most may not be used depending on the quality of the raw water or the source of the water. But we will begin with sunlight exposure. For this technique, the following equipments are required. We need a disposable clear plastic bottle. Glass bottles should not be used because they do not let enough sunlight into the water. We will also require bright sunlight, And the process is as follows. Fill a clean bottle, leaving a quarter empty. Put the top on and shake the bottle for 20 seconds. The bottle should be left in sunlight, usually on the roof of your home, for 1 day or 2 days if the sky is cloudy. Drink the water straight from the bottle to avoid cross-contamination. In the rainy season, paint one side of the bottle black. This will increase the water temperature quicker. The painted side should be placed underneath. This technique has the following advantages. It kills harmful bacteria and pathogens. It is also simple, convenient, and inexpensive. If used correctly, the water is as clean as boiled water. It does not change the taste of the water. Disadvantages: it will not remove mud from the water, and the waiting period is about 6 to 12 hours. The next technique we are going to treat is chlorination. The equipment required here include household bleach, also known as eau de javel or javel la croix. We will also need a water vessel, a stirrer, and clear wastewater possible. The process involves boiling the water for 5 minutes and then adding the bleach to water. Note: the amount of bleach added depends on the quantity of the water, and the greater the quantity, the greater the amount to be added. For example, in a 1.5 liter of water present in a bottle, you can add 3 drops. Stir thoroughly. Let it stand for at least 30 minutes. The advantages of this technique include: it is an easy-to-use technique for the purification of water. It is effective at killing bacteria and viruses. Disadvantages: it is not effective at killing all parasites. Complex compounds can form with organic materials, which over time can be hazardous to health. It is best to use the water in a shorter period of time and store it in a plastic container in a cool and shaded place. We will proceed with coagulation and flocculation. The equipment required here include a coagulant such as aluminum sulfate, two vessels labeled A and B, a stirrer, a filter funnel, or a white cloth. The process entails adding a coagulant to water and stir rapidly. A coagulant is being added to water containing impurities. The coagulant forms precipitate, trapping the impurities. The precipitate and trapped impurities thereby settle to the bottom of the container. This coagulant is added to assist in the removal of particles suspended in water, such as clay, bacteria, and fungi. Allowed to stand for some time and continuously stir slowly to form large flocks. These flocks are formed as a result of simultaneous chemical and physical interactions on and among the particles. Therefore, within seconds, the negative charges on the particles are neutralized by inorganic coagulants, thereby forming the flock, which is a metal hydroxide. The formed flock clean the water by attracting pathogens and other microorganisms. Burn a cloth and place it on the top of a container. Remove the flock carefully using filtration and be careful not to recontaminate the water. Advantages of this technique include it reduces viruses, bacteria, and even protozoa present in water. Pesticides and heavy metals are also removed. Disadvantages of the technique: it may be toxic if used improperly. It could be more expensive and complicated than other methods due to increased number of required materials and skills. It requires multiple steps. Let's proceed with another technique, which is filtration. The equipment required here include a porous barrier. It can be a clean woven fiber such as a cotton cloth, lining, and so on, or ceramic filter and water vessel. The process is as thus: fix the barrier on top of the water vessel. If using cloth, it should be folded 4 to 8 times to create a thicker barrier. Pour water through the barrier into the vessel, trapping solids and other particles on top of the barrier. Take care to only allow filtered water to reach the container. Note: letting water collected during the day settle overnight can be an effective way of improving the clearness of water by reducing turbidity, very milky water. And it is a cheap alternative to sand filtering. The process is as thus. Picture A shows a lady fetching water. In B, she placed the water in a container. In C, she allows the water to settle. D, the water has settled. You can clearly see the solid impurities at the bottom of the container in black. She now pours the water into another container and allows the solid impurities in the first container. And in F, we have the clear water ready to be filtered. However, you must leave the water undisturbed for a sufficient period of time, at least 10 hours, out of sunlight at night. In a sealed container is best. Warning: this technique must be used in conjunction with filtering. This is only a pre-treatment to make filtering more effective. Advantages of the technique: it is not expensive. It provides us with immediate access to water. It filters out all particles that are larger than the pores in the barrier and can be cleaned and reused. It does not alter the taste of the water. Disadvantages of the technique: it does not guarantee the removal of all viruses, particles, and infectious contaminants, chemicals, pollutants, and poor taste. It cannot be used as a sole purification method. The last technique we are going to see here is the three-part treatment. The equipment required here include 3 water vessels or pots for processing, that is, 1 for the collection of dirty water and 1 for the collection of clean water. A cloth or any filtration barrier if possible. The process involves pouring water into the first pot. Pouring it through cloth increases efficiency. Let the water settle for as many hours as possible. A length of just 1 day can kill more than 50% of most bacteria. Pour the water into a second pot and let it settle again. Then pour it into a third pot and let it settle again. The picture below shows you water which has been allowed to settle in the 3 pots. Drinking water is drawn from the third pot only. Advantages of this technique: it is not expensive and easy to use and maintain. Bacterial contamination levels decreases through settlement and over time. Disadvantages of this technique: it does not guarantee complete removal of bacteria and microorganisms. It could take a few days to treat water. With regards to water purification for laboratory use, there are some specifications that lab staff and technicians should consider. A well-specified water purification system from a trusted and experienced supplier will provide an exceptionally high level of purity and ensure your lab receives an efficient, economical, and reliable supply of purified water. The techniques used to obtain this high level of purity include distillation. This technique involves heating water to boil and produce water vapor. The vapor contacts a cold surface, also known as a condenser, where it condenses as a liquid and is collected in a round bottom flask. Using this technique, 99.9% of pure water can be obtained. The next technique we are going to say is reverse osmosis. Reverse osmosis is theoretically the most towards methods of large-scale water purification available. In this method, the water supply is fed under pressure into a module containing a semi-permeable membrane that is capable of removing up to 98% of inorganic ions plus virtually all microorganisms. So, if we have a salty water, in this salt water, there are inorganic ions such as sodium ions and chlorine ion present. These ions contaminate this water. The semi-permeable membrane is capable of removing these inorganic ions from the water in order for us to obtain fresh water, which is pure. The last technique we are going to treat under the techniques of purification of water for laboratory use is deionization. This method involves connecting ion exchange cartridges directly to the main water supply. Each cartridge uses a mixture of resins to remove anionic and cationic contaminants from the fed water. The strong acid cation resins will remove cations from the contaminated water, while the strong base anion resin is going to remove anions from the contaminated water in order for us to obtain treated water. For further information on purification techniques, you may read Science Textbook for Class 7 from page 22, page 222. Thanks for your